So model deployment. Essentially, at this point, right, we'll talk a little bit first about just the whole machine learning pipeline before we go any further into this kind of portion of model deployment, because model deployment is really the last, well, I would say the like last kind of step in the machine learning pipeline, right? First, you've got to have your data, then you have to train some data, so on and so forth. So before we move on, let's just talk about that really quick. First, there's the concept of having your data. So where is your data? Is it in HDFS? Is it as an object in, say, S3 or GCS? Is it stored in a data warehouse like Snowflake, or maybe in a database like KDB for time series, if you're doing, like several banks use KDB for time series data. Essentially, knowing where your data is and how to get it is probably the first step in your machine learning pipeline. And this is important for model deployment because the most important part about model deployment is actually getting your data and making predictions on it, right? So basically, from there, you're gonna take your data, and wherever it is, you're gonna bring it into your machine learning pipeline. So that is the process of training an algorithm, training an algorithm to generate a model artifact that will make the prediction. So this could be something simple like a linear regression, where you basically have a bunch of x betas or betas that are going to be predictive on each of the columns in your data set. Or it could be something more complex like a random forest, or even something more complex like a neural net. So the process of training your model can be done with several different libraries, inclusive the H2O core library. So that is basically our open source product. So from H2O AI, there are two major products, H2O core and Driverless AI. Now, Driverless AI is the closed source, and actually the model that we're going to be deploying today is actually from Driverless AI, but we'll get a little bit further into that. And there are other libraries such as scikit-learn is another good one, some Spark libraries as well. Once you've gotten your trained algorithm, typically it's, if you're using scikit-learn or if you're in H2O, it's somewhere in memory. It's some conglomeration of bits and bytes in memory that have just kind of been stored there for you to export later. So if you're in sklearn, you'll pickle it. In H2O, you can actually use a couple different processes, one of which is Pojo, so plain old Java object, or Mojos, so memory optimized Java objects. And basically what they do for you is give you different methodologies for which you can deploy your model artifact after it's been generated. So what we'll do now is actually go into the slides a little bit, but this is we're going to start with the open source, but this is basically the core H2O architecture for our open source. And as you can see, you start on the left, that's all your data. So data from sources like HDFS or S3, or even just from your local disk or from a SQL database that you've thusly queried. Once you bring the data in, you're going to bring it into memory. And this is, with H2O open source, one of the benefits of having H2O open source is the fact that it's really good with large data, and it can be the data can be distributed, or the whole process can actually be distributed across multiple machines in memory. So this allows you to handle, terabytes, exabytes of data, as long as you have a machine large enough or multiple nodes of machines large enough to handle it. Inside inside H2O, you can actually parse the data. You can do some EDA. You can even plot or do some feature engineering. And finally, you can create the models. Right? And then finally, you can then export those models into the aforementioned Mojo or Pojo, which is how you would be able to deploy them into your infrastructure. So a lot of times this can be a difficult process, especially for customers, because they are, in their own special world, right? Some people use Docker to deploy their models. Some people use Kubernetes. Some people are just deploying them straight from their laptop. Who knows, right? But every customer's infrastructure is always different. And so the practice and the art of deploying models into production can be very unique to each customer, which is the reason why things like the Pojo and the Mojo are so useful. As you can see at the top of the slide, you can actually just do pure in-cluster scoring. So that simply is you had some binary object created by H2O, and all you've done is imported it back into the cluster and scored on that. But what that is simply just probably for you to test the model prior to actually deploying it to your actual production infrastructure, because this is not scalable. It's not really that useful for pure production level scoring. And next, then you have the Pojo and the Mojo. So inside H2O, you can have a couple different ways of deploying for in-cluster scoring, basically just using the APIs, so either R or Python. And for the most part, it's pretty straightforward. You basically have a model that you can save or load. It's a binary object, or it's just a simple binary, and then once you've loaded it, you can simply predict on it again. Very similar to the idea of like a scikit-learn pickle. Sorry, I'm kind of going through some of these slides fairly quickly, but basically this stuff is kind of not that important to what I really wanted to get into, which is how to deploy the Mojos ultimately. So Pojos are kind of like the stage one of like how to deploy in Java, and they're supposed to be lightweight and efficient and easy to deploy, as we're going to see in some of the sample code that we have coming up next. But essentially what we're looking at here is you have a couple Java calls, and all you're doing at the end is just making a prediction. And all you have to do is pass it a couple different pieces of information, a couple parameters based on the number of features, whether or not it's supervised or non-supervised learning, so on and so forth. And so that gets us to this slide right here. So basically, model training into model management. Model management from this perspective is actually not really model management. All you're really doing here, or what we're saying we're doing, is just storing the models and just giving them as like an available repository for you to download, which is not really model management. Typically, when we provide this to you, the idea is that it's a generalized object that can be managed by your own infrastructure, by your own preferences. A lot of people will use the models in production, and they'll send, an additional scored data or previously known data back to the model in order to verify whether or not it's degraded over time. And then on, say, hitting a threshold of, 80% accuracy, they'll then discard the old model, retrain the new model, kind of thing. So that's the idea of model management, is the idea of like having a repository of models, but also being able to manage them and test them, qualify them over time. And that is something that's actually quite easy with the Mojos, in the sense that they're very lightweight. You just deploy them and then they're good to go. But it is not something that H2O would do for you, is essentially what I'm trying to get at here. So this slide kind of talks about the idea of training versus deployment, which is what I was getting at earlier. Basically, you have the concept of, you have your data, which you've ingested. You've done some feature engineering. You've done some model training. Now you have a model. What do you do with it, right? Basically, the difference is deployment is using that model to get new predictions. So taking new training data, exporting your training data pipeline, which can be done in Spark a lot of times. There's Spark pipelines to do the feature munging prior to passing the data in. There are other people who can use HDFS, or just even R is good for doing feature munging as well. Yeah. So once you've deployed it, now you get into predictions. So basically, at this point, we're going through a quick slide of examples, but one would be, serverless deployment of your Mojo, right? So in this case, this one was a model trained on the Iris data set. It's a very common data set. I'm sure most people have kind of seen it before. Obviously, you're predicting whether or not, what type of flowered is based on like sepal length and petal length. And basically what you can do is in Lambda, you can provide it a couple different parameters under which if you give it the Mojo as well as some other parameters, you can basically just say, okay, anytime I get a response, pass it to my AWS Lambda endpoint, and it will make the score for you. Sorry, I will just admit that this slide deck was not built by me. I do apologize. So we are going through it fairly quickly, mostly because I want to touch on a couple other things that are not entirely in this slide deck. Yeah. Okay, cool. So we've gotten through that one. All right. So basically, what I'm getting at here, and essentially what it comes down to, is the concept of model deployment is very different for every different workspace. And so what I'm actually going to show you eventually is a demo of how to deploy it in what I would think is a fairly unique workspace where we have a database serving it real-time data. And basically kind of a proof of concept of how easy it is to take that object, that model artifact, that Mojo, and put it into a deployment scenario. Now, I'll be running it from my Mac, but you could also do this in Docker. Basically, all the commands you could put in a single SH file, and it could be run as the Docker endpoint. It could also be run off a Kubernetes cluster and scale. Basically, there's a whole bunch of different options from there. Now, first, before we start, just kind of before we get into that, I'm going to kind of quickly show you Driverless AI. Now, this is our closed source product, and the reason why I'm showing you this is because the Mojo that I'm going to be using is from Driverless AI. So just to give you guys kind of a bit of context of how it was generated is what I want to do. So I'm going to do that one, this, and give you a notebook. Okay. So basically, this is a sample notebook that I wrote for one of the partners that we have. And what it's doing is just a couple things. It's really simple. The really cool thing about the Mojos is that there's only one dependency, and that's Java. You don't need anything else other than Java and the machine to run it on. You don't need any crazy Python libraries. You don't need any crazy like C libraries or compilers. All you need is Java. And that's one of the kind of major values of using the Pojo or the Mojo is simply that you just take the Java jar object and you deploy it. So now that we're there, this is Driverless AI. Now, this is our closed source product. You do have to pay for a license in order to use it. If you are interested in trying it, you can get from our website a 21-day free license trial to use it. And this can be run, recommended anything bigger than a laptop, but you can also run it from your laptop. So first, I'm going to kind of show you the UI, but basically there's the idea of where is your data, right? So initially when I talked about it, right, I said you can bring your data in from places like Hadoop, you can bring it in from places like Amazon, you can also bring it from other databases that need to be queried like KDB. So in this case, we're going to do it from KDB. I'm going to make a test file that's called test.csv just because I have the data set in here already, so I don't need to redo it. But I can actually write a simple query. And now this will not look like SQL, by the way, because this is not SQL. This is a language called Q. It's specific to the KDB dataset or database. But basically, all I'm doing is telling it to select the entire data set from the Walmart train table. And I can click to make the query. Now, if I take a look here, I'll actually show you that this is the data set that I'm querying. And it's just exposed as an endpoint right here. And that's what Driverless AI is actually selecting. Once the data set comes in, you can see it appears as a new data set. Now, this is our own special version of data type called data table, and this actually helps with Driverless AI's ability to do expansive levels of feature engineering and model tuning and hyperparameter training, which is not something that's going to be part of this. But if you are very interested in learning more about Driverless AI, I would encourage you guys to try and find a way to H2O World. So those are the little pamphlets that were on your desk. Otherwise, we have plenty of other meetups throughout the year, so you guys can always learn a little bit more about that. Now, what you can basically do is you can take a quick look at the data set. You can run what I did, which was clicking visualize. Basically, what that does is give you automatic visualizations of the data set. So it'll give you outlier plots, correlation graphs, so on and so forth. And you can click on all of them, and they're all fairly interactive. So just kind of briefly, just showing you what's going on here. Once you do that, now you have your data, right? So now the next step is to make an experiment. So I've done a couple experiments here, including the one that was done really quickly on our data set. But basically, you have the opportunity when you're setting up the experiment to select your score. You can also select some specific tuning settings. So like, how much do I prioritize accuracy? How much do I prioritize time? How much do I prioritize interpretability? We can get a little bit more into driverless AI if you guys are interested, but I'm just going to breeze through it so that we can get the model. But ultimately, what we've done is we've downloaded the Mojo scoring pipeline. So in case you're curious, this is the Python client that would have done the exact same thing. So we imported the H2O AI Python client. We logged in, and then we downloaded the data sets that we wanted, created some experiment settings that we then sent to the server so that we can create the experiment that was run. And then we built the Mojo pipeline and then downloaded it. So what did we end up with? Mojo pipeline. So this is the Mojo pipeline. So this is coming out of Driverless AI. Now this is version 2 of Mojo. It's basically Mojo 2.0. But essentially, it's much the same as the original Mojo. The original Mojo is what you'll get in H2O's open source. Now, the major difference is that this one requires a license in order to use. That's like more or less the big one. But other than that, we've also built in the algorithms that are actually used in driverless AI. So, in the in the open source Mojo, there will be the algorithms that H2O3 has available, and in driverless AI, there will be the algorithms that driverless AI has used. So those are the two major differences. Basically, what you're looking at is you get an example CSV of your data set. You also get the more important one, which is the actual Mojo object. So if we look at this, the example Mojo is a couple hundred megabytes, 200 megabytes is basically what this is, and that's fairly small for a model artifact. And when you deploy it, it's actually quite lightweight. So what we're going to do now is deploy it. Now, what we have here is, now this is actually open to the public, I believe, but basically what we have is a Java jar object that we've written that will basically consume the Mojo and then also connect to KDB and then receive new data from it and make new predictions and then push that data back to KDB. Okay, so let me just write that one. Let me just write out the command. It may just take me just a second because I don't always remember without actually having to read it through. Minus CP KDB.mojo. KDB, H2AI, KDB, Mojo. It takes a lot of work for me to actually remember where all my files are. And that's 90% of the work here. Okay, minus H, minus P, 5010, minus sub, copy paste this. Actually, let me just do that whole thing here. Okay, so just in case you guys are curious, but all I've done is pass it a jar file, which is the compiled code for reading in data from KDB, and then consume the Mojo and spit out data afterwards, right? I've passed a couple flags, but basically, where is the Mojo? Where in KDB do I look? So that's the host name that you see as well as the port. What is my command inside KDB to subscribe to the new data? And where am I publishing it afterwards? That's basically all that's going on here. So after we run it, as you can see, it threw an error that is asking for my license key. Okay, and we'll run that one more time. So you won't see much, or basically the way I have this going is that it will start to print out the new predictions, but that's not really that cool. All it's done is, it hasn't actually written it back anywhere, right? All it's done is receive the new data, and then it started printing new predictions. So if you actually go to, or if we run another Java object, or another process in a separate page, I can do this right here. Oops. Java -cp H2O workspace Mojo libs /H2AI DAI subscriber jar db.mojo. And cool. So I'm going to make this just a little bit bigger. But basically what you're seeing is a live stream of the new data that's coming in. So as you take a look here, it's outputting new data. So this is the new predictions. So as I got new data, I made a prediction on it. Those are the predictions that you're seeing here, and I've just kind of printed it out as a pretty way of predicting or seeing it so you can actually read it. But that's what's happening, and it's basically every second there's a new set of 2 rows coming in that are then being predicted on, and then now this is what you get back. So every second you're getting new updates, and these are being pushed into KDB for you to consume in other ways. So this took me maybe 5 minutes, and most of it was just because I forgot, the class paths. But basically that's kind of the power of deployment of Mojos in any kind of infrastructure. Now, of course, this is just running on my laptop, but you could be doing this, again, from Kubernetes or Docker or what have you. In fact, the KDB server that's running is actually running in Docker. So what we're doing is actually calling a KDB server from Docker, or that's in Docker, and then taking the new predictions and then putting them back in. Cool. So that kind of quickly covers the concept of model deployment. At least this is the core of what I really wanted to cover today. And I do apologize if this is a little bit of a shorter discussion. This was kind of last minute for me, but I would love to open it to the floor. I'm very much better with answering questions than I am about kind of giving speeches. So yes, please ask as many questions as possible. Yes, sir.
After deployment, how do you evaluate the performance of the model? In what sense do you validate the model is performing good or bad?
Right. So now this is very simple. This is a simple deployment. All it's doing is reading the data, taking the Mojo, spitting it, reading the data back. But the Mojo itself does come with a couple of different pieces of metadata attached with it, so you can use it in kind of a model artifactory kind of way. Now, we don't provide a way to test a model in production, offhand, right? So we're not going to give you the way for you to test your own model, is essentially, but a lot of the best practice surrounding this, and this is something that several different customers have done, is I've seen where the model is deployed in Docker, and it's basically streaming data in and receiving, and basically during that time, part of the data that they stream in is new known data as compared to, say, just new unscored data, right? And in doing so, you can basically receive the new predictions and you can then compare yourself. So a lot of times people say, I want to optimize for MAE or something like that if it's a regression, or maybe log loss if it, or AUC if it's a classification. And from there, when they receive the new data, they can compare it and measure against the metrics. And the nice thing about actually Driverless AI is that Driverless AI has the concept of model checkpointing. So if, for example, you've deployed model A into production, and say 3 or 4 days down the line, the model's starting to degrade. So you originally were getting maybe 86.86 AUC, for example, and you want to say that your threshold is 0.83 for model degradation, right? So as soon as it hits that threshold, basically you can use the Python client, which will interface directly to Driverless AI and say, hey, Driverless AI, I need to retrain a new model, take the original model that I have, and feed it the new data, which, of course, as we were talking about earlier, we know where it is, right? So feed it new data, retrain a new model, and deploy it. So the only thing that would be kind of specific to your infrastructure is, assuming this is, you know, a .py file and not an IPython notebook, right? But I mean, it took me 1, 2, that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 lines of code to train a model, right? I mean, if you deployed this in a Docker container somewhere, basically all it's doing is telling Driverless AI, which is running on the edge somewhere, train my model. And this could be H203 as well. You could be running an H203 cluster, interface with it using the, and this can be entirely automated. That's the really cool part about this, right? Is that you can be using the cluster, train your model, download the model artifact into your, already set up container somewhere. And then from there, whenever it triggers that rebuild, it basically just sends a call, an API call down to your cluster, builds the model again, downloads the model back in, and basically you can even have a simple shell script that'll degrade, remove the model artifacts around, so you can move from mojo.pipeline to, or pipeline.mojo to pipeline.mojo.back or whatever you want, and then just move the old one, the new one into the original spot, and there you go. Restart your Java process, now you're predicting on your good model again. So, I mean, sorry, I kind of lost track of the question, but basically when it comes to checking for degradation, typically it's something that most customers have done on their own because they have a very specific will or need for it, whatever that may be, their own specific infrastructure or their own specific metrics. Some people even score against like 7 or 8 different metrics in order to judge whether or not something's degraded. Yeah. Any other questions?
I feel most people use Python libraries to train models. Mm-hmm. What does the process look like for you to take a model that you trained in Python environment and converting it into Mojo, and what are some of the problems that you face?
So Mojos are kind of, I wouldn't say they're proprietary, but because they're not, they're open source. Sorry, I really shouldn't say they're proprietary. Basically, the process of converting a Python object into a Mojo, unfortunately, I haven't done a ton of work on this, but it has been a lot of development on our side. I mean, we literally have like full-time engineers working on this. I think the team has expanded from 2 to 3 or 4 now, working on specifically creating Mojo runtimes for this. Essentially what it comes down to is there's a lot of the back-end work of actually defining what the model looks like in Java or in C. The Mojo ultimately will have a C++ runtime as well in the near future. So it's not easy. We do it, and we have to basically write the algorithm for each of our algos, right? So if it's a random forest, you have to write the algorithm in Java for the random forest or in C++, so on and so forth. So typically you don't see a ton of it unless someone's pre-written it for Python. Yeah.
So why do you choose Java? Like, there's a process of converting, there's a cost to it. Why not just deploy in Python? Oh, sorry.
That's a good question. Honestly, some of it comes down to scalability. The other part of it is kind of the concept of parallelism. So the Mojo, typically Java processes occupy a single thread, which means that if I had a machine or single process, right? So you can sometimes pin it to multiple cores, but there's the concept of single threadedness, and it's also a lot faster. So technically, if you had, say, a 10-core machine, I could run 10 Mojos in parallel. Or usually the case would be something more along the lines of like 8 in parallel, and then have a two threads occupied by a load balancer to distribute the load. Or you could, well, I mean, I'm spiraling, but basically the idea is that you can have multi-threads on a single process, which allows you to have a lot more throughput. And the Mojos have been benchmarked to be actually significantly faster than Python scoring pipelines in general, because they are compiled. So that means, especially when you get to the kind of concept of doing your feature engineering inside the Mojo. I apologize, that is actually one major difference from the Mojo 1 and the Mojo 2, is that Driverless AI actually does feature engineering when it generates the final experiment. So what you're seeing is actually a full engineering pipeline. So you ingest the data, Driverless AI will do feature engineering and then train a model, and then iteratively weed out bad features, add good features, and then train a final model on top of that. So your final pipeline for Mojo 2 is actually feature engineering plus predictions. And so when you consider the whole pipeline, doing it in Python is actually quite slow, especially when you have to use like pandas. But with the Mojo, it's actually really, really fast. So that is one massive difference, and I do apologize for leaving that out originally. Yeah. Yeah. That being said, Driverless AI does have a Python scoring package as well, for obvious reasons, as you would probably understand. So it does exist. Yeah. Any other questions, thoughts, concerns? Yearning for pizza? No? Cool. All right.